Well, welcome everyone to GeoHug. So if you can all just jump on mute now for the presentation, but we will be opening up the floor at the end. So don't be shy. Let us know your questions or any comments that you have. But yes, Rick Valenta, thank you so much for joining us today. So Rick is the director of the Bryan Mining and Geology Research Centre and the acting director of the JKMRC at the Sustainable Minerals Institute at the University of Queensland. And I'm so happy that he can join us today, and he'll be having a chat to us about translating research into discovery. So thank you so much for joining, and yeah, so appreciative. So thank you.
Thanks very much, Jessica. I'm just going to share my screen here, hopefully. And I see, can you see that?
Yeah, that's perfect. Yep.
Great. All right. I don't think I need to see myself. Back one. So I guess before I get going, I'm not sure I chose the right title really. After I got my talk together, I thought, is this the right title? But anyway, that's the one I'm going with, because all the other titles sounded a little bit more lame, like my half-baked ruminations on translating research into discovery, or some things I've done in this area, or other titles. But I'm going to stick with this one anyway, because I am going to be talking about that, or touching on it from time to time. And I want to start as well with some acknowledgements, because a lot of what I'm talking about has come out in the last few years as part of a quite large project we've been doing with the Department of Natural Resources, Mines and Energy, the GSQ in Queensland. So I've listed a whole bunch of people there: Tony Knight, Helen Deschling, Vlad, Matt Greenwood, Courtney, and many more from the GSQ, as well as my colleagues at the BRC, Paul Gow, Nathan, Mark Hinman, Karen Connors, many more, as well as the other collaborators on this project. So, and you know, as people usually say in this case, I don't mean to say that all these people agree with what I'm going to talk about, but I certainly want to acknowledge their contribution. And the other thing that I want to do that's a little bit out of the ordinary for a talk like this, I guess, is to start with something that's a little bit sadder, and that is that Mark Hinman, who has been with the BRC since 2015, and sadly passed away last week after a couple of years of illness at the age of 62. So at quite a young age. Mark's a huge loss, and I know that I see from the people online already that many of you will have known Mark and worked with him. I've just included on this slide as well a couple of pictures of things that that Mark was involved with previously, but and his picture's going to turn up in a couple of other places as well. So Mark's had a huge influence on the work that we've done, and was a fantastic geologist who will be very sadly missed. And the other thing that I want to acknowledge before I get going is that a lot of the things I'm saying, people would be thinking, why is he saying that when there are all these fantastic initiatives going on that he's not mentioning? So I wanted to mention them right up front. They are fantastic initiatives. Exploring for the Future, now into its second iteration. I'll be showing some data from that in a second, or towards the end of the talk. But a fantastic initiative. The MinEx CRC, the work that has gone into thinking about exactly the sort of topic, I guess, that I'm touching on in terms of the Uncover, the Uncover initiative, and of course many other university initiatives. So just because I'm not mentioning them during my talk doesn't mean that I'm not aware of them. It's just I'm talking about my stuff. So I want to dive straight in and talk about open the talk by talking about the project that forms the basis of some of these thoughts, which is the Northwest Mineral Province New Discovery Program, sponsored by the Queensland Geological Survey of Queensland, the DNRME. And the reason it came about was that the mines in the Mount Isa region, that's a picture of the copper smelter, are maturing. I guess the copper operation has been recently announced. It's going to go on for a little bit longer, but the mines are maturing due to and there are obviously social and economic implications for that. There's also been a bit of a lack of exploration success in the last little while, though there's a very strong base of study in this region. And so that's pretty typical of a lot of regions that are known world-class mineral provinces that are coming towards the end of their life. And another thing that typifies that sort of region is that a lot of the potential may be either undercover or deep and partially blind. The other thing I think that's it's not something you could apply absolutely across the board, but when I compare current situation to say the way it was 20 years ago, I think there are declining technical resources for companies. They don't have the same level of technical support and budgets and specialist support that they might have. Everybody's being expected to do more with a little bit less. And of course, the increased junior presence in the Mount Isa region, but also, almost anywhere you would care to mention, means that whatever exploration is being carried out has to be done on an even more compressed time frame with an even stronger kind of feedback to the external world required, and a lot more promotion. And of course, in Queensland, at least, when you get two geologists together, it's not going to take long before they start talking about the various extra responsibilities that have been placed on us in terms of things that we need to do in order to get land access and social environmental responsibilities that are really part of the world that we live in, and they're only going to get more stringent as time goes on. And of course, the other aspect to this, I guess, is that all of this exploration is being carried out against a framework of I guess area selection and refinement that I'm sure a lot of you are very familiar with. So those of you who know this kind of timeline or this procedure from back to front, I'm not assuming you don't know it. I'm just really talking about it in light of the the thoughts I've had on it. Where you start with a concept and you could apply it to anywhere in the world, and then you apply a set of criteria based on actually I'll step back to the world at the level of the world. The concept you might apply may be modified by your company strategy, the commodity you're interested in, the market, anything like that. When you get to region selection, obviously that's where mineral systems modeling is very important. And I think we saw a great. I sat and went through John Ronsky's talk from a few weeks ago, and I thought it was a fantastic example of that. And I'm certainly not going to repeat that talk. But the mineral systems modeling and jurisdiction factors are important at that scale. And then you go to the camp selection scale, and this is a set of tenements from the northern half of Mount Isa moving into the MacArthur region, actually from Red Metal, showing camp scale exploration plays they've selected, and then down to target selection, prospect exploration. And this is from a group with which I've had some involvement in the past, Kenorland Minerals, who just made a high-grade gold discovery in the Abitibi, and then down to resource definition drilling. And of course, most of you would know, and many people who've commented on this have pointed out that the cumulative expenditure is not unlike the COVID curve that we're seeing a few places around these days, and that is that area selection is vitally important. It's pretty cheap. It doesn't cost millions of dollars to do area selection. What does cost you millions of dollars is if you select the wrong area and then spend a lot of money down the track, because as time goes on in this process, you transition obviously to much more detection and then into very drilling intensive exploration, and the expenditure goes up enormously, and in some ways the risk goes down, but in other ways the risk goes up. And I've been down this track with a number of discoveries, some of which are now in production. But I guess what I want to argue talk and use to justify why we're focusing on a slightly different part of the exploration cycle, if you like, is that I would like to say that a lot of the research that we've done in the last little while, and actually for a very long while, has been very focused on this relatively early stage, the mineral systems modeling stage of exploration, and that there's a justification, and I guess I want to show you some examples of work that I hope will help explorers more at the detection and prospect exploration stage. And I'm going to try and use an example to show you that this is just as vitally important as the earlier mineral systems modeling, whilst acknowledging that if you've done your area selection wrong and picked up an area and explored where there is no potential, then you've done your money for sure. So I'm not belittling that part of the work. And now I want to come back to talk about, in that context, to talk about the Northwest Minerals Province. And I know that I haven't really introduced the geology. I think a lot of you probably know a little bit about Mount Isa geology, and I'll show a little bit more about it later. But what I want to talk about is discovery history in this area, and it's not unlike discovery history in a lot of areas. So what we've got here is a timeline across the bottom from 1954 to 2014. And we've got different colored dots for different discoveries. And of course, there are discoveries off the back end of this diagram. Most notably, of course, Mount Isa, George Fisher / Hilton, a whole range of Dugald Rivers. So there were early prospecting discoveries, but what we've got is these light yellow dots that are prospecting, the more orange geochemistry, the red geophysics, and the blue drilling. And what we've seen is a progression from 1954 to 1994 of I guess a predominance of prospecting and or geochemical discoveries, but mainly prospecting, moving to a spate of discoveries in the sort of 1984 to 1994 period, and a move to much more geophysical discoveries undercover. Things like Ernest Henry, Cannington, Osborne, that many of you would have heard of, as well as some more geochemical discoveries. And I'm not going to go through. Paul Gow in an ore deposit seminar a couple of weeks ago talked a little bit about some of those discovery histories. I'm going to focus in on Century in a second, but what I want to focus in on in this slide is to show that in the Mount Isa region, what happened was that just about at the same time that we had this spate of discoveries, we also had a spate of research studies, and anything I would say about these research studies should be tempered by the fact that I was involved in a few of them. So anything I say bad about anything anybody did there, just remember that I was part of it. So I'm not, I'm certainly not throwing stones. If I'm throwing stones, I'm throwing them at myself. But there were a whole range of studies that started at that point. The Australian Geodynamics CRC, the PMD CRC, CRC Leam, more on regolith, the neighbor study by Geoscience Australia, an MIRA study on the ore deposits, and then a whole range of studies looking at regional compilations and 3D mapping and just really a whole range of studies, as well as ongoing university studies. But what we also see is that through all that time, there were very little new discoveries. So I guess the background to this slide, or the background to why I put it together, is that at the start of this rekindling in about 2017 of a regional new discovery program, we wanted to look at what had been done previously and say, well, what lessons can we learn from that work, and what can we do to try to improve the discovery rate, given that what it appeared was that in general, all of these studies that took place in the Mount Isa region, which were quite heavily focused on regional target selection and understanding of continent scale controls on mineralization mainly didn't really lead to additional discoveries. And so you might say, well, okay, so they didn't lead to exploration success. Why is that? And of course, I think that to say that that those studies were a failure is completely wrong. There was just an enormous amount of really good insights, academic advances, advances in process understanding. A whole range of really good things came out of it. So why didn't they lead to more exploration success? And there are a whole bunch of questions there. Was there nothing left to be found? Well, I don't think that's the case. There certainly was an exodus of majors at the time, and it was related to some other developments related to native title and land access. And of course, this one is one that we did want to explore, which was, maybe the studies didn't really have a sufficient link to exploration outcomes or some of the exploration challenges in the region, or maybe they weren't at an appropriate scale, or was there a problem in terms of industry take up? Did those studies take place but nobody actually make any use of the information, or were there other factors? And I mentioned a couple already: the moratorium, changes in company strategy. There was an exodus of majors, but one thing that did come out of it from the work that we did, from the work that we were planning, was it was really hard to make a compelling case to say, well, we're just going to do a few more studies like the ones that just took place over the previous 20 years that really didn't lead to exploration success. And the other question that we asked was, can we actually make better use of what's been done already? But what I wanted to do now is actually to switch gears a little bit and use Century as an example to talk about, I guess, the appeal of doing some of the regional scale area selection of the type that I've been talking about and others have been talking about, but also some of the pitfalls associated with it, and to try to justify some of the things that we've done since. So probably a lot of you have seen this quote before. Everybody's got a plan, but sometimes the plan doesn't work out exactly the way you expected it, and that's certainly something that applies very strongly to exploration. So I guess the first thing to say, and this is the first a map I've shown, the regional magnetics for the Mount Isa region. I don't know if you can see my mouse. I'm going to turn it into a laser pointer here. So the Mount Isa sitting in here, George Fisher, Century, Cannington down here, Ernest Henry, a whole range of different deposits. But when you look at the sediment-hosted base metal deposits, for example, I mean, this is one of the best endowed sediment-hosted base metal districts on the planet. So there's not really any doubting in this area of its raw prospectivity, or that the sort of fertility and crustal lithospheric scale processes were operating. There's no doubt about that. And actually, this is taken from a presentation at the PDAC in 2018. Bits of it were taken from David Houston, but also from Roger Skiro's recent Skiro et al.'s paper on work in the Tennant Creek Mount Isa region, which sort of looks at the kind of regional area selection approach. But what I'm going to say is that for the Mount Isa region, if you're exploring in the Mount Isa region, which is what the aim was of our project, you didn't really have to worry about the availability of the energy, metal, and fluid sources to produce the mineralization, whether it's sediment-hosted silver, lead, zinc, or whether it's IOCG style copper gold, or whether it's an ISA style iron sulfide gold, because it's clearly those processes are clearly operating. And in terms of the mineral system component, in terms of architecture, fluid pathways, and I guess the favorable host situation, I mean, it's an area where the regional structures relatively well understood. I'm not going to go through the details of this, but it's an example from work that Pete Betson team put together, just looking at the structural history for this region. And it's been refined since, but it shows a strong, or I guess a well understood history of structural, I guess the tectonic history of the area. When you look at targeting criteria and an application of those in the magnetics, here's an example from the Lady Loretta region. So Lady Loretta sits in there, is just a tilt processing of the raw magnetics, and you can see these blocks of Eastern Creek volcanics defining, and you can see the cover, the subtle anomalies associated with the cover rocks here, and the deeper, more blocky anomalies associated with the underlying basement and underlying basement structure, and the strong control of these underlying basement intersections on the localization of mineralization. So I guess the criteria you would use to select target areas in this region is pretty clear. There's gunpowder as well. And then we look at favorable hosts, and this is another thing taken from David Houston's presentation from the from that PDAC meeting. The Gun, Loretta, and River supersequences have long been recognized, I guess, as the host for sediment-hosted base metal mineralization in the region. And over here, this is just one of the products that we produced as part of this project, which was just to say a coverage that allowed you to time slice all the stratigraphy. Very simplistic work, but what it means is that anybody could go to the website, download a workspace in ArcGIS, MapInfo, or QGIS, and say, I'm interested in the distribution of age equivalents and active structures for the Gun, Loretta, and River sequences, and bring it straight up, and isopacks from the 3D models and that sort of thing. And you can see in there a whole series of, when you look at the active structures during that time, you can see similar intersections. I'm focusing on this area because that's where, as you'll see in a second, the Century deposit sits. And so this is actually a coverage, again, from that compilation that we've done of about 7 or 8 different targeting exercises that were spread around the internet and in various different reports. So another thing that we developed as part of this work more recently was to just pull all those targets together into a single thing. So anybody who wanted to, from industry, who wanted to go to this area and say, well, what targets have been developed for this area, could bring them up. And in this case, these are Mark Hinman's targets, working along with Vic Wall, both now who've left us sadly, for sediment-hosted base metal deposits in the western succession of the Mount Isa region. And then in terms of a temporal control, and this is based on work by Geoscience Australia, the apparent polar wandering path, quite clearly is identified the temporal disruptions that are probably an important control on why we're suddenly getting the formation of these base metal deposits. And I think the first time I heard John Ronsky and Cam McQuaig and company talking about, and I'm sure others might have talked about it before, but they were the first ones I heard about it, where they were saying, here's the theoretical justification for why these distinct events are controlling mineralization. Made a lot of sense. So let's just step back now and have a look at some of the data sets for here. So we're looking at the magnetics over here, again, the tilt magnetics, and I think anybody could see that there are a whole series of structures and blocks that you would identify as part of that. When we look over here, we're just again showing that those prospective supersequences, and in this case as well, known mineral occurrences. So these are known lead zinc occurrences. Lots of them were known. Most of them were known from well before any of this work started. And so this is an area, this nest of occurrences over here has been an area of small scale mining since the late 1800s. And if you plot the density for the whole Mount Isa region, you end up with this absolute searing bullseye right in here. And you would say, well, my work here is done. I've done my area selection. This is clearly the highest priority target in this area. Not only does it fit the process model in terms of everything, but it's also got very strong empirical support in terms of distribution of known mineral occurrences. There's no major ore body there. It's got to be a no-brainer. So we've gone through this whole decision-making process, identified this as a target, and anybody could say that, and of course that's Century, right? So it couldn't be more obvious. And 9 times people got to this point, picked up ground on that target, did their exploration, and walked away. There it is. So it's from Graham Broadbent's paper in 1995. These are all the tenements. And that's the position of that little dot there, is the position of Century for all those 9 different tenements that were held over the deposit. And these are all the exploration traverses and drill holes that were carried out in the area of this deposit. So the whole, and not all these tenements were picked up on the basis of necessarily on the basis of mineral systems modeling, but I think they were all picked up on a very strong basis. But what they didn't do was recognize the mineralization. And what I'm going to show now is what was then CRA did, which was and Paul talked about this the other day as well, a crisscross of traverses. There's a soil traverse going across, and this is from our mineral deposit atlas, basically showing the lead and zinc geochemistry of that traverse sitting on top of the Century deposit, and then more detailed soils that followed, and the eventual geometry of the ore body. And then there have been an enormous amount of studies since then that have revealed many really interesting things about Century as a deposit. But I'm going to take another little deviation here now and refer to another one of my favorite quotes, which was, "It ain't what you don't know that gets you into trouble. It's what you know for sure that just ain't so." So what we knew for sure at that time was based on our understanding of Mount Isa, which had been operating for a very long time at that point. And I and many other people, including people like Ken Maiden in the audience, who I saw before, and others no doubt have worked on it. And one thing that there's a map turned on its side, so north is to the right, following the Urquhart Shale in Mount Isa. This red blob is the ore body. And then this is a diagram from Matt Painter's thesis, which was finished in 2003 here at UQ, taking all these widely spaced drill holes covering the halo to the Mount Isa ore body. And in this case, we're looking at the distribution of fine-grained pyrite in that host Urquhart Shale. Over here, we're looking at manganese. Over here, we're looking at thallium. And what we're seeing here is that there's an enormous halo associated with this deposit, way bigger than the actual deposit. And that's good, right? Because, and you look at that halo and you say, well, this is clearly a geophysical target. There's lots of sulfides here. So any target, if I pick up a bit of ground, get a tiny little anomaly, but don't see a whole lot of mineralization and don't see any pyrite, that obviously means that it's probably not much good. And you can, and we have put together a whole sort of set of criteria that you would use to characterize the copper mineralization, the lead zinc mineralization, the area within 1.5 kilometers there in terms of what the carbonate mineralogy was, what the a whole range of different sort of lithogeochemical patterns, and I'm not going to go through them all here. Some of the work done as part of the Amira study led by Codes in this area developed a whole series of criteria for vectoring in lithogeochemistry in the halos of these deposits. And Matt Painter developed his own ISA vector, and there were stable isotope patterns. There demagnetization, or demagnetization of the basement, a drop in magnetic susceptibility, a whole range of different criteria that you could use for Mount Isa. And then when you look at a post-mortem for Century, you could say that you had all the criteria there that were showing what you wanted, but what was missing was dense conductive pyrite halo. So there was absolutely no Cyrotem response. It turns out there was an IP response for Century, but on that basis, and on the basis of the subtle nature of the exposure, it took a long time to find Century. And that's going to lead me to another deviation, which is we all say that we're doing science, but I want to say is mineral exploration more like science, which is where we're applying the scientific method and saying, well, we're going to develop a hypothesis that such and such a type of ore body is present, and then we're going to develop a test to test that hypothesis. And if the test fails, it will move on. Or is it more like jazz music? And you might think, well, probably not like jazz music, and probably not in a lot of ways, but jazz music is all about innovation. And Clark Terry, who's played with an absolute who's who of the jazz greats, had a very simple philosophy to becoming a master at jazz music, which was 3 words: imitate, assimilate, innovate. So the whole idea was that you start imitating what other people have done. You look at what they've done. In the case of exploration, we work with people who apply certain techniques to different areas, and become familiar with those techniques. And then as we work on more and more of them and work with a greater range of people and look at more and more data sets associated with mineralization, we assimilate that approach so much that it becomes second nature, and we develop a much stronger understanding of what to expect, what things look like. And then finally, we develop our own ideas on how to improve on those sorts of exploration techniques to detect mineralization at the expensive and risky detection stage. So that brings us to one of the biggest initiatives that we did as part of this project, which was the Northwest Queensland Mineral Province Deposit Atlas. And the whole idea there, and the reason I put this up is that Paul Gow gave a talk on this the other day, and I'm not going to recreate that talk, but was to say that instead of re-prosecuting the mineral systems models that were reasonably well developed, though not 100% developed for the Mount Isa region, we felt that it was going to be important instead to develop something that would allow people to have all the information that was available associated with the halos and signatures of all the major deposits in the region. And so when they drilled a hole in the middle of nowhere, they would have a reference to compare that hole with, and perhaps better understand what they had intersected, and assess it in terms of its favorability. And all of those, this link down here will get you to all of the deposit atlases. They're now available online, as well as on the new data portal for the GSQ. Or you can just Google BRC Deposit Atlas, and that will bring it up as well. And there's the YouTube link for Paul's talk, where he spends a lot more time on this. And like all the other ideas I've talked about, I didn't come up with it myself. I stole it. So the stuff I talked about before, I pretty much stole from Cam McQuaig and John Ronsky and their co-workers, where they were saying also that we have this transition from prediction at the regional scale to detection at the local scale, at the prospect scale, and the cost goes up. It becomes more challenging. In fact, they made the point, how do we do better at the detection stage, where the big money gets spent? At the same time, there was a study going on in Canada called the CMIC Footprints Project, where they were looking at 3 different deposits, much more detailed than we were, but trying to document exactly that, so that the next time somebody was exploring for a deposit like that, they didn't need to just imitate that deposit. They have assimilated, in the case of Mount Isa, they've assimilated all of the different halos, and could therefore come up with an innovative understanding that would allow them to recognize elements of those halos and eventually maybe teach a machine learning algorithm to recognize elements of those halos. And the part of this quote I didn't put up here. So imitation is the sincerest form of flattery. The rest of the quote is that mediocrity pays to brilliance. And somehow I didn't feel like that part of the quote was one I wanted to be associated with. So there's the footprints concept again. And it's one we followed where we basically wanted to pull together everything we had and put it into to a deposit atlas. And when we did a survey of industry, that came back. And this is just, everything on the right-hand side is strongly positive priority. On the left is lower priority based on industry feedback, a large amount of responses. Everybody was quite keen on having a deposit atlas like this. So we put one together, and now we've covered about 28 different deposits, but in about 21 different volumes of basic geology, ore body geometry, geochemical signatures, halo minerals zoning, updated geology, solid geology in covered areas where we had to, trace element zoning, and even zoning in the inner halo. So we're looking at different elements here around Ernest Henry, for example. So I see him going over time, so I'll hurry up. And in addition to, so this was all in a PDF volume. In addition to a PDF volume, we compiled all this information into a 3D compilation. So what we're looking at here, for example, is it's a little bit subtle here, but you can see these drill holes, the Ernest Henry ore body, a zone here showing that this mottling in here is geochemistry on the unconformity based on sterilization drilling. This is the MT recently collected by the GSQ in the region, showing again a big low resistivity finger that points straight up at the Ernest Henry ore body, and a number of other low resistivity fingers in the region, and inverted magnetic susceptibility. So we've basically compiled everything into a 3D atlas. So in terms of the current state of that, they're all available as Myra Geoscience Analyst files, about 21 atlases, and multiple regional models, and they also include drill hole data, drill core, high logger data, TEMA data from CSIRO, rock property data, everything we could put together for all these deposits. And again, just search UQBRC Deposit Atlas, they'll all come up. They're stored in Geoscience Analyst, which is free. The challenge associated with that, and we've also put together compilations of all of the previous 3D models for the region that have been collected over the last 20 years that were stored in various different formats that required old versions of $50,000 software or couldn't be opened at all. So we put them all into a free and easily accessible format. The only problem with that free and easily accessible format is that once you put one deposit into it, even if you had a pretty grunty computer, that was where you were finished. So all the models were stored as separate files. There was no potential to compile all this 3D information into one spot. And also, the way we're delivering that data now is that it's being stored as static zip files that people download. There's no ability to update or change that data. So what I want to show you now is really just an early work in progress, but we've been working with a company called Euclidean who's developed a program called udstream, and we're actually using that information to and the advantage of this program is that we can actually store, we have the potential to store all of the data that I just talked about in a single online source that can be accessed without downloading any software. I'm running software in this case, but it can be accessed from a browser and can be just updated. If you want to update this file that I'm looking at now, you just add some more files to your Amazon web server bucket, or the survey does so, or anyone, and you can do it that way. So this is just a tiled image that I've uploaded of the regional magnetics. It's actually the recent Geoscience Australia compilation of the magnetics for the whole region. There's Mount Isa there. There's Cloncurry, and we can put in things like there's the and you know, not, this is all possible as well on a, you know, if you've got the data and want to load it up into other pieces of software. But there's the recently completed Exploring for the Future AusAEM data that's been made available in relatively easy to access formats. So we were able to pull that in relatively easily. One of the products that we produced as part of this program was a compilation of all of the interpretations that had ever been done by anyone in the Mount Isa region. And as far as I know, this had never been done before. So there were interpretations that were done by private groups. There were interpretations that were done by members of Geoscience Australia. There were interpretations that were done as part of our Deep Mining Queensland project. If we single out, you know, an area, for example, you know, I was talking about Century before, so we can go have a look at the interpretation that was put together by MMG for Century. So I'm just going to turn off 06GAM2. So there's their a little bit of it anyway. There's their interpretation. The other thing that we've done is we're able to load up. I won't spend too much time on this because I'm running over, but all of the 3D model for the region. So that's available and can be loaded up in a browser and manipulated without, you know, one of the big problems with loading this up into a piece of software is by the time we've looked at this amount of stuff, unless you've got a really grunty computer, you're in trouble. But now let's take it a bit further and say, let's say that we are interested in having a look at, you know, Cannington. So there's the it's hiding down here. There's one high logger hole for, oops, sorry about that. There's one high logger hole for Cannington. And I won't be showing the high logger data, but you know, in this universe, you can zoom straight down to a piece of drill core, and Moronin is another system that's like Cannington. So you can say, rather than having to get rid of the Cannington geoscience analyst coverage and go look at and open up the Moronin one, in this system online, we can just say, actually, I'd like to look at Moronin rather than Cannington, and see how Moronin compares. And so now we can look at the core from Moronin. And in fact, the whole idea is that all of the BHT type systems, or all of the IOCG systems, that we could load up all the core for all these different systems. And so you know, in the case of Mount Isa, and that'll be the last one I look at, then we'll go back. So we've got a series of, and with all these, we're in the process of loading up all this information, but I'm going to turn off the regional data. The solids. So, you know, what we've got for Mount Isa is a bunch of drill cores. We can see we've got the AusAEM and sections from the Isa compilation that was done probably about 20 years ago now, just looking at the geometry of the silica dolomite and the different ore bodies, and showing, you know, again, if you zoom in there, you can go straight down to say, okay, well, that's a hole that's gone through the base of the silica dolomite in this area. What does it actually look like? And you can go down to that level. So I've probably spent enough time in here, but the whole idea is that instead of having a whole pile of different coverages. Let me get back in this. There we go. instead of having a whole pile of different coverages for all these different atlases and regional compilations that we put together, what my vision is that we have all of that data together in a single source that can be accessed all at once. That includes all of the data from regional scale, all of the fantastic data that's been collected at lithospheric scale under the EFTF, all the way down to mineral liberation analyzer level, micron scale, pictures of the texture of different styles of mineralization that are available to explorers to refer to in a way that's easily updatable. So that's kind of, it's a little bit off the topic, but it's kind of one of the things that I'm a little bit excited about right now. I know I've gone over time, so I'm just about done. But what I do want to say at the very end is that I didn't acknowledge any companies at the start, but you can well imagine that putting together an atlas like this is really dependent on supply of data from a whole range of different companies, and all of these companies have provided us data to put into those atlases, and when you think about it, that basically means those, because unlike a lot of projects we're involved in, where the first thing you say is, yes, we'll sign a confidentiality agreement, make sure that we're absolutely tight-lipped about whatever we've done with your data. All of these people were approached basically on the basis of saying, hey, give me your data, I'm going to make it available to everyone. And they all did. So why did they do that? And I think they did that because they realize that there's an enormous benefit in making your data available, that the advantage that you can gain from having a repository of information pertaining to the mineralization all over the region supplied by everyone is far greater than the benefit that you can gain from jealously guarding your confidential data and everybody else jealously guarding their confidential data. Because, and I know that I'm preaching the converted here, because I think all these companies, and probably a lot of the people in the audience, I mean, I think we really have to remember and remind people that we're not working for greedy mining companies and carrying out research to facilitate greedy mining companies. We're working to ensure future mineral supply to the world so that we can actually accomplish the energy transition that we're setting out to do, number one. And number two, that we can afford a lifestyle for the other 6 billion people on the planet that don't have what we have through additional mineral supply. And the only way that we're going to do that is by making discoveries. So again, with that, I'd just like to thank all of you for your time, and I hope we get some discussion. Thanks again.
Thank you so much. I was nearly getting teary in there because I saw my core trays.
All right. Oh, that's good.
Okay, we have had some stuff coming through. One that made me giggle: explorers are spoiled these days compared to the 80s. One comment. All right, so excuse my ignorance. If Merlin was a drilling discovery, what does it mean? I.e., none of the other 3 conventional discovery methods.
Yeah, basically there was a known system very close by, and so it wasn't really something where people went out, or as I understand it anyway, where people went out and targeted something completely different and applied a different geophysical technique to detect it. It was much more drilling next to an area where there already was known mineralization, just deeper and a little bit along.
Can you estimate how much time and costs are saved as a result of the availability of these data? You implied that the availability of the data also reduces risk. Presumably, this could be interpreted to mean a better chance of discovery in a given time, assuming that deposits to be discovered do in fact exist.
Okay, that's a really good question. I think that you know, and I've listened to a few people. I remember actually at the start of the Predictive Mineral Discovery CRC, I think it was Bruce Hobbs, who was talking to a bunch of us, and you know, we were talking about whether we were going to go out and gather more data, and or whether we were going to sit on the data that we had pretty much and just interpret it. And his response at the time was, you are never going to have enough data. Your job, if you say I'm going to keep gathering data until I'm done gathering data, you're going to just keep gathering data. It's never going to stop. So I mean, I guess that's a little bit off the topic of the question, but I think the time and effort, it's not so much time and effort that would be saved. You know, in the case of Century, for example, what could be saved is the danger of going to an area, drilling a hole, not recognizing that you were in the halo of a world-class system and walking away, which is what happened, which is what has happened numerous times in various different deposit settings. So I don't know how you quantify the benefit of that. And you know, there really are two different ways to approach this, because some people look at you know, there's always sort of two different kind of discovery histories. There's a discovery history where people claim, or where they sort of attribute their success to a systematic, well thought out study that proceeded exactly correctly down the progression to drilling and hit the ore body in a timely fashion. And if you don't do that, then you should just walk away because you're just wasting your time. And then there are other discoveries like Century, I guess, and also like Cadia, where dogged persistence and rethinking a number of disparate indicators have actually led to success in an area that was known about for a very long time. And I think that the sort of compilation that we're doing, the whole idea of it is to allow people to have the best possible idea of the range of I guess possibilities for what a halo might look like associated with a mineralizing system, and what the vectors might look like that would allow you to um, to make a discovery in a system like that, um, in the knowledge that it's never as simple as I think people make out when you get into an area like that, and think that if an ore body's there, you're obviously going to find it. And then the last statement, when you said if an ore body actually exists, I am absolutely 100% confident that more ore bodies exist. Every time I've worked on an area where people have said everything's been found there, there's nothing more to be found whatsoever, there's always more to be found. And you only have to look at, and I got rid of those slides because I knew it was going to go over time, but you only have to look at the covered area of the Mount Isa region and the small amount of data that's available there to know that there are going to be more discoveries made in that area, and the geological knowledge of that could be extracted from a single drill hole in light of all the other halo information is going to be of utmost importance in that area, because there's no possibility to do surface geochemistry or prospecting. I see a hand up.
Yes, that's
I'll
what I'm
let you.
saying.
I'll
John,
let you be the.
John, did you want to jump off mute?
Yeah, surely the honest answer to that question is I'll tell you in 50 years.
Yeah. Yes, that's always that's always a good thing about these sorts of things. You know, when I'm sure a lot of you have heard this expression, but that's all well and good. Let's get the rotary lie detector onto it.
Seems you have a good ally answering some questions about the Euclidean stuff. So a lot of that, but some just good comments. You could spend all day in there, all year. Yeah, so it looks like it's a lot of impressed people in the crowd. But thanks, Steve, for helping with that. Rick, some explorers being bold and looking pretty deep. What do you think their chances are?
Look, I think it's a it's always going to be more difficult exploring undercover, but it's still got to be our best chance as well. So you know, all of the efforts that are going on by various different groups to improve our chances of success under deep cover are really important. And I think that the sort of halo footprint and vector studies that are going on by us and others are utterly important in that, because you know, you're going to end up with a situation where even the biggest companies are going to drill, you know, they might drill 5 or 6 holes and not find what they need. So what they need to be is the absolutely the most informed that they can be in order to constrain, in order to I guess guide further exploration, because they don't have a lot of the stuff that they can get people excited about when it's sitting under 500 meters of cover. So it's obviously longer odds exploration, but it's also you know, it's the virgin territory that we have left, and you know, exploring under deep cover in an area like the Mount Isa region is, I think, you know, it's a long shot, but at the same time, at least you've reduced one of the risks, which is you know, the potential for hosting of world-class deposits. You can tick that box for the Mount Isa region. So so that was a long answer. The short answer, I think, is good, but yeah, whether it takes 5 years or 25 years is the question.
Did anyone else have questions? It's you're welcome to jump off mute now. We can open up the floor if anyone wants to say anything.
Hi, Alison. Oh, hi, Robert. Yeah, go ahead.
Hi, Rick. So you touched very briefly on how, you know, we're gathering all these sort of sparse data sets, which, you know, a lot of the time we're doing over here in Zambia as well. Now, what are your thoughts on when you sort of make that call? Because like you say, you can carry on gathering data sets all you want, but how do you make that call perhaps to gather all the sparse data, for example, that you have, and perhaps put it through machine learning or whatever to try and make sort of decisions on the data you have at any given point, I guess?
I think I've the it's, I mean, it's a very good question, and you know, I know that there are machine learning routines, for example, that help with that, where they'll look at a, you know, when you're gathering sparse data in a certain area, that you can on the fly look at the variance within that data and say, well, it looks like basically on the basis of what we've gathered here already, we don't need to tighten up the spacing. Whereas suddenly, if you get into an area where you're getting what seems to be an enormous variance from point to point, that you can gauge that you need to collect more data in this area. And I think honestly that machine learning is better for that sort of thing than it is for being let loose on a data set to identify targets. Because I think what we generally do is, you know, when we develop machine learning algorithms to identify targets, we have this, and I'm not the first or probably even the 500th person to say this, but we have this situation where the area that we most want to identify targets in is the area in which we have the least information. So there is no information that, you know, so you're using an incomplete data set, or you're using a one that is you know, it's just not sufficient to the task. But actually what I'd like to try to do, and it's sort of related a little bit to what we've been trying to put together, and that is to use machine learning for you know, for an approach where you could let's say, and I've had this experience, you've drilled a hole in the middle of nowhere, and you've got anomalous copper in that hole, and you've got a mineralogy, and you've got a lithogeochemistry, and you've got a texture, and you've got a you know, a whole series of data, and you might gather hyperspectral data over that whole whatever, and then rather than just saying, well, you know, what you often do at that point is bring in an expert, or whether it's internal or external, who looks at that data and thinks about what it might mean. And they, like all of us, are going to apply their cognitive bias. It's going to be based on what they've seen, what they've read, and it's probably going to be incomplete. But it could be very much complemented by a complete data set of mineralization in that region. Say in the Mount Isa region, if you're drilling under 500 meters of cover in a similar setting to the areas where we've got a whole series of drill holes where we have hyperspectral data, where we've got mineral liberation analyzer / TMID data, where we've got multi-element geochemistry, rock property data, and everything in a database where we take that new hole and we plug it in, we profile it, just like when you log on to Twitter, the advertisers profile you and decide what sort of ads to feed you, and we could do that for this hole and come back with an assessment of whether it looks like it's sitting in the halo of an Ernest Henry style system, or an Osborne style system, or some other system, or what its affinities are, what's the encouraging, a whole range of different things that's using all of the information that's available. And I think that a machine learning / data analytics approach like that could almost be more fruitful than one that's going out into the, if you were gonna, I was thinking of all the points of data we have in any region as a light map, like the light maps of the Earth that you see, where we're going into the very darkest region and saying, let's map in this extremely dark region where we can't see anything, using really clever machine learning. And what we'll find is that, well, if you can't see anything, it doesn't matter how clever your machine is. And then the other point to make on that is that, and I don't know if this is right, but one of the guys on our advisory board said that there's apparently some sort of hybrid chess competition now where chess grandmasters, guided by computers, will do battle against each other in tournaments, and he said that the only thing that will beat the most intelligent, the most, the biggest and nastiest chess program run by the fastest, most formidable supercomputer on the planet is a chess grandmaster with an iPhone chess program. And I really think that the approach of having a gifted explorationist guided by exactly the sort of thing that allowed John McClellan and Paul Pearson to win the recent South Australian competition, where we have two fantastic geologists doing machine learning, doing geomechanical modeling, using those outputs in a human intervention guided way to identify and rank targets. So sorry, that was a very long answer, but I hope it at least addressed your question.
No, it does, Rick. Thanks very much for that. Cheers.
So what you're advocating is essentially a digital assistant.
Yeah.
To the sort of thing that certainly in some areas we already do. I'm more familiar with porphyry copper environments, but you get awfully tired of enthusiastic young geologists interpreting every chlorite pyrite assemblage as propylitic and therefore 4 kilometers away from the big one.
Yeah.
It would be really nice if we had a massive amount of data on that small lump of rock that we have, or strip of core, which could say, sorry, buddy, that isn't peripheral to a porphyry.
Yeah, I think that's absolutely. I had similar experience in when I was leading a team that was doing porphyry exploration, where you'd have people take you out to the field and they would scrap around. They'd find one little bit of shreddy biotite and said, "Look, we've got potassic alteration. The porphyry's just around the corner," and the porphyry is not just around the corner, because if they'd had a resource where they could actually look at what what you look at when you're what it looks like when you're 400 meters away from the porphyry, it might have helped a lot, both from the point of view of visual cues, texture, lithogeochemistry, mineralogy, mineral chemistry of the type that Dave Cook and his team are doing such a great job on, and so on. Geophysics, everything.
Of course, part of the solution to that issue is taking your exploration team to go and visit real mines where these things are kept in captivity and not running around the bush, hard to find.
Yeah.
And I find that there is decreasing amounts of money available from anybody to fund just taking industry geologists as groups off to see the local elephant.
It's a very good point, because I mean, I sincerely believe, and maybe in the future this won't happen anymore, but I really do sincerely believe that when you go visit deposits, your brain takes in things that you never see in a paper and that you never are able to quantify, but it's got them there and it's processing them. And the next time you see something, I've had this experience where we worked on a few epithermal projects in the Desierto Massif in Argentina, including kind of one that got away. And the next time I saw something similar, and I can't even remember why I thought it was similar, but it was working in Turkey, looking at some fairly scrappy little veins, and turning to my colleague and saying, we've got to get this project, and it's a mine now. So it's there are a whole series of things that are harder to quantify that you can recognize. But what I was going to say as well is that as part of this program with the Geological Survey of Queensland, the other thing that we're doing, and this is Courtney Dinarum and Vlad Lisitsyn and company, is in the Mount Isa core facility, putting together a library of drill core from all of the major deposits. So yes, you can go do a virtual tour, but as you say, people don't have budgets and time for necessarily to go, to go on a 2-week jaunt, looking at every single deposit in a region. Some groups do, but what you can do is go to the Mount Isa core library and look at drill core that's been donated by all those companies that I mentioned before, or as many of them as we can get, and actually see the rocks, at least in drill core, and in many cases both from the mineralization and from the halo, and of course if they're a target that's under 50 meters of cover, well, that's the only thing you can see anyway. So yeah, but it's a indispensable part of the whole picture.